Alright, so we're in business here. This is the first video for pre-algebra. This is Mr. Mashad, and I'm going to help you with your homework tonight. Again, just the back side of that page I gave you in class. Let's start with Joseph wants to find the side length of a square that's an area of 150 feet. Should this answer be rational or irrational, and why? He's looking to find the area of a square. Visually, a square has the same length and width. So 150 by 150. Now the area is going to be length times width. So we're expecting the answer to be rational. So we're going to do 150 times 150. Times 150. 22,500. Of course, that is rational. It's an integer. It's a large integer. Also, we talked about how it terminates. It ends right here. Irrational would be a number that goes on forever as a decimal, that does not repeat and does not terminate. This is rational. This is called an integer, and it terminates right here. So rational. Which value from the following list of numbers is not a rational number? So which one of these is irrational, is what we're looking for here. From this group, we know that this is rational. This is rational because it terminates, it ends right there. All fractions are rational. If you'd like to check this one, you're welcome to. As we talked about in class, when dividing, you're either going to get a decimal number that repeats or terminates. So all fractions will divide and get you a repeating decimal or a terminating decimal. This one repeats. Repeating decimals, although they go on forever, are rational. So this is called a pattern. There's a pattern of fives there. So this is rational. 5/9 is 0.5 repeating. If you want to write it down, 0.5 bar on top of the 5. The square root of 25 we talked about in class is 5. That's also rational. 5 is 5. 5 terminates. Right there, it ends. 0.321, 321, 321, 321. That's repeating. Repeating is rational. So again, terminates. This one repeats. This one repeated. And this one over here terminated. So our last option must be the correct answer. The square root of 30. If you'd like to take out your calculator, you can. But we talked about how the square root of 30 falls between the square root of 25. Square root of 25 is 5. The square root of 36 is 6. So the square root of 30 falls in between there. So anything that's not a perfect square, any value that is not a perfect square, will end up being irrational. So there are a lot of square roots that are irrational. 30 square roots. Looks like I don't have one on my calculator. If you're in that situation, you got to have a little better idea of roots. So I realize this calculator does not have a square root button on it.
Filling the two-guard, please come to the main entrance. Filling the two-guard, please come to the main entrance.
All right, so you hear the announcements there. Yeah, so that's, if anything between there and there, square root of 26, square root of 27, square root of 28 is going to be irrational. 29, 30, 31, 32, 33. All those square roots in between here will be irrational. Brad converted 5/11 to a decimal, and his result was a repeating decimal. Does this mean that the value is rational or irrational? It means that it is rational. Also, any fraction where the numerator and denominator are both numbers that are integers will be rational. The reason why I say integers, it has to be integer values on top and bottom or in the numerator and denominator, is that you cannot tell me that pi over 1 is a fraction. I know you did a fraction bar there, but the numerator and denominator both must be integers, and pi is not an integer. Again, a reminder of what an integer is, that integers are whole numbers, both positive and negative. So both positive and their opposites. So just an FYI there. State whether the given values are rational or irrational. For A, this is rational. It terminates. It ends after the 7. For B, the dot is telling you that it's going on forever. So 3.4567 irrational. 3.4567 with the bar on top of the 7 is repeating. Repeating is rational. There is a fraction that will make that number. Okay, 2 more to go. Number 5a, we have the square root of 30, which is irrational. We addressed that earlier in question number 2. If you take an irrational number and you add 6 to it, you will still end up with an irrational number. For that matter, think about pi. If I have pi, which is 3.14156, if I take pi and I add 2 to pi, so I'm taking basically 3 plus 2, I'm going to get 5.141562. It's the same irrational, well, not the same irrational number, it's an irrational value. I just added, something to it. Now, letter B is more interesting. We have 6 plus 30 underneath the square root. So what you end up having is this. So all inside the radical, the square root is 36. What is the square root of 36? 6. Therefore, this is rational. Now you took this and separated it. What is that going to do? So the root 6 and root 30 are separate. The square root of 6 is an irrational number. So I'm going to put here irrational. Plus the square root of 30, which is irrational. If you add 2 irrational numbers, you will end up with an irrational number. It won't magically become rational. So adding irrationals will yield another irrational number. If you don't believe me, do pi plus pi. Or do this right here. Square root of 30, square root of 6. Try it out. Oh, I don't have the button here. I'll use my phone. All right, so square root of 6. You do this on your phone, if you have an iPhone at least. It's the one that looks like, better focus here. I'm going to zoom in a little bit. All right, right there. Yeah, it's having difficulty getting it. Can't really see it. Looks like this in the iPhone. That. So you have to trust me, or you can try it out. And an irrational plus an irrational will be irrational. Last question. Give an example of an irrational number that is greater than 10. So we got to figure out an irrational number greater than 10. So let's just pick one out of the A here. Let's see. The square root of 50. Now, the square root of 49 is 7. So 50 is going to be a little bit bigger than that. So 7 is not going to be good enough here. So the square root of 50 is a little bit bigger than 7. That's no good. Let's go bigger. Let's go the square root of 100. The square root of 100 is 10. So that is rational. So I'm getting closer to an answer, but I don't have an answer yet. So I'm looking for an irrational number that is greater than 10. So just the next number up. Anything bigger than the square root of 100. So square root of 101 will be 10.1 da 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 da. So anything bigger than the square root of 100 will be correct. Any number, the square root of, but make sure, I shouldn't say any number that's not a perfect square. So you cannot do the square root of 144. The square root of 144 is 12. That would be rational and not irrational. So we have to do square root of 145. All right, if any questions, please bring them to class tomorrow. That's it for this homework. Hope it was helpful, and see you tomorrow.